So I'm Kip Merker. I'm a product manager at Google. I work on the Google Cloud Platform, specifically on the container engine, the container registry, and Kubernetes, which is what we're going to talk about. So here we go. Okay, so kind of think of like compute as a continuum. This is kind of just getting, thinking about like putting in context of how we think about computing. On the left side, and you can go even further and say, hardware and bare metal, but VMs, virtual machines, as its basic running computer that you can use for building your software. And then on the right side, you kind of have your platforms and PaaS type solutions. And there's this thing sort of right in the middle that we're focused on, which is container clusters. And that's where Kubernetes kind of fits into the story. So you're building containerized apps, letting them sit in a cluster that's manage that for you. I'll get into what that means in a little bit. So first of all, what is a container? So everybody's familiar with VMs. I did the show of hands thing earlier. Who's familiar with VMs? Like everybody should go. A couple people? All right. A few. Let the record show that no one raised their hands when I asked them about VMs. Containers are kind of like VMs. They're a way of getting them kind of using VMs, a way of managing VMs. They're not a replacement for VMs, which I think is an important thing for people to realize. We don't recommend use containers as a security boundary, for example. It's got a shared access to the host OS. But what's really cool about them is instead of making a replica of the OS for every single instance that you're running, you share a kernel, you share the OS, and then you just bring what you actually need to run that portion of the application inside of that container. Okay. So people always ask me about like the relationship between Docker and Kubernetes and container engine. So walk through that a little bit. So Docker is the actual open source project that there's a company as well, but the open source project format that we use for the container runtime. The set of tools and a registry where images are stored, where you can share images with other people. And it lets you basically take that container and deploy it on your laptop, on a server, or in the cloud, which is great. You can run it pretty much anywhere. But that's kind of the single atom of a portion of an application running in one container. Kubernetes orchestrates across multiple containers. So you can take a piece of your application, whether that's a web front end, database back end, some middle tier logic, maybe a BI system, mobile, et cetera, whatever happens to be running in those, same way you would with VMs, orchestrates across those. And it keeps the complexity hidden. So you don't have to worry about like the fine-grained commands and controls of how the container lifecycle works. It does that for you. You declare what you want, and it's going to keep it in that state. And I will go into that in more detail in a little bit. And that's also an open source project we released last year from Google. Tons of contributors working on that from Red Hat and a bunch of other companies and individuals. We just had a meetup 2 weeks ago in San Francisco where basically all the major contributors to Kubernetes got together in a room and hacked for 3 days, which was super fun. And we can run Kubernetes pretty much anywhere. It runs on AWS, it runs on Azure, runs on DigitalOcean, runs on bare metal, runs on OpenStack. We just announced fairly recently that we're doing OpenStack. And there's PaaS solutions built on top of it, like OpenShift and some others. So that's Kubernetes. And then the container engine is Google's cloudified offering of Kubernetes. It literally is Kubernetes. It's the same experience, the same tool set. It's just running on Google's infrastructure. So Google Cloud Platform is based on the same infrastructure that Google runs worldwide, and the same stuff that's being used for YouTube and for search and Gmail and everything else. Cloud sits on top of that. So you're really getting kind of a great cloud platform that's the biggest in the world, and then using Kubernetes as a way to easily deploy containerized clustered applications. Okay, so that's the kind of the overview of. But what are actually our our containers? This is a quick overview of them, but I kind of talked about all this already. The key thing is that they're lightweight. You can think of them as a packaging a portion of an application. They're hermetically sealed, meaning that they run everything inside of the container. You have to make explicitly, if you need to call out, you explicitly do that. And you have resource isolation from the other containers running side by side. So you can think of like the noisy neighbor problem where I have if you had two processes running on a VM that they can consume each other's resources, they have a shared pool of resources. Containers provides an isolation level where you can limit the amount of CPU access, the amount of RAM, et cetera, that each container can use. So you can actually get better isolation, and you don't have to worry about the guy next to you taking up your resources, which is a pain. If you've ever been on an airplane. Anyway, moving on. So how are they actually implemented? There's some Linux APIs that are used across containers. There's actually a bunch of different container technologies that are out there. Zones and jails, C groups, et cetera. So there's a lot of different ways that sort of containers are implemented. And these are the key things. I won't go into all this, but these are like the different things that make it possible. This is the magic that actually makes it work. Yeah, so literally everything that we run at Google runs in containers. This is part of why we're kind of moving into this containerization model. This is what Google's been doing since the beginning, way before my time. But all these products that you see here, even GCE itself, the Google Compute Engine, is actually running in containers. It's actually VMs running inside of containers on our infrastructure. And so 2 billion containers per week, which is a massively mind-blowing number. Yeah, it's a lot. And that's, we took kind of the expertise, this is kind of the origin story of Kubernetes. It was a bunch of engineers that were working on this internally. They thought, why don't we make a version of this that we can actually export into the world and let people start using it the same way that we do? We love using it internally. It makes our lives easier. It means you can run scale like this, but it actually scales down pretty well too. So you don't have to be, this is one important thing to realize, you don't have to be Google to run your applications in a googly way, if that makes sense, right? You can actually have a much smaller service, but then you're set up for success so that if you do get hit with the, high-class problem of having, 1 million people show up at your site unexpectedly, then you can actually, you're prepared for it. And all these different reasons, performance, repeatability. Yeah, containers spin up way faster than VMs. It's just part of the physics of it. It's just there's less to do, and they're highly optimized for speed. I'll show you a little of that in a second. Repeatability, you can take the container image because it's a kind of a sealed image. You can repeatably deploy it. I already talked about isolation. Quality of service, meaning that you can measure them. You can see them as individual units that you can treat in a kind of a homogeneous way. All containers are kind of the same, if you will. Accounting, meaning that you can look at how resources are being used by different applications, and you can do that, again, in a very consistent, kind of principled way in terms of managing visibility into how your resources are actually being consumed, because you have these boundaries. It's kind of like Lego blocks. And portability, being able to move stuff around. And actually, portability with Kubernetes is a big part of it. I already talked about Kubernetes running in all sorts of different places. What that also means is that if you build an app on Kubernetes, you will be able to move it between different environments. So if you're concerned about lock-in, which some people are with cloud providers, you can leave it any time, which is kind of nice. All right. Docker. This is the Google search results, Google Trends interest in Docker over time. I don't know what happened exactly in January. There's a little dip, but they recovered very quickly. So Docker's been kind of it's been getting a lot of media attention. They've been doing really, really cool work, lots of adoption. And it's a really easy to use tool that enables containers, which is awesome. It's an implementation of the container idea. It's a packaging format. It's an ecosystem. It's a company. Open source juggernaut. It is kind of a phenomenon. It's like kind of this rock star thing that's happened to Docker. They've really kind of taken off, which is awesome. And so from our perspective, we want to help extend that even further with containerization. So these are all the sort of things that you need to think about when you have a container, right? Once you have a container, singular, now it's like, what's the next step? And this is kind of where Kubernetes comes in. And you can look at all these different issues we talked about already. But these are kind of the things you need to think about when you're running a large scale or even a medium scale application that's composed of microservices in containers. I had to put that microservices shout out in there. I was going to do a contest on this one too. Did anybody know the origin of Kubernetes before I just showed this? Did anybody know the origin of the word? No one, not a one. Okay, so now you know. Oh, he knew. Okay, good. You get a sticker too. Here, can you hand that to him? Thanks. The stickers these are actually the old stickers, by the way. So these are probably will be worth something on eBay someday, I'm sure. Anyway, so yeah, it's Greek for the word helmsman and the word governor. And so that's kind of where the name came from. We shorten it sometimes as K8S because there's 8 letters between the K and the S. So if you ever see that, that's what that means too. Yep, and you can run on all sorts of different stuff. It's written in Go, which is super cool. And we have a good community of people working on it. And if you want to contribute, you're more than welcome to join in and start coding. There it is on GitHub. I don't know why that's in here, but it is. It's proof. It's proof. It's really there. Yeah. All right, I'm going to give you a quick demo. We got a couple lined up, so is it okay so far? Pace, good, good-ish. Yeah, all right. Cool. Let's see some stuff in action a little bit. So, silence your phones, please. Come on, don't be that guy. All right, so I'm going to show you something. This is an application right here that is actually running in a Kubernetes cluster on Container Engine in Google Cloud right now. So I can sign into. Actually, anyone has, oh, you guys don't have your laptops. You're such a good audience. You don't have your laptops open. But if you did, you could go to this URL right now and you could say, hello, DevOps and cloud people, hit go. Right, look at that. It shows up right there. So this is actually a Redis backend, web front end, super simple application. It's running in a few containers. If I pop over to my Google Cloud Platform Developer Console, you can see my guestbook app right here. If I drill in a little bit, I can actually go see the VMs that it's running on. Because guess what? Containers are running on VMs that are running on top of containers that are running on top of VMs that are running on top of computers that are sitting on the turtle on top of the anyway. Sorry. So I'm going to go into one of these dudes right here. Actually, what I'm going to do is I'll show you. So if I click on this end thing, you can see this is actually running on node 1, all right? And it changes when it refreshes because it's a clustered application. But if I SSH into this box right here with one click, pretty cool. Get a web-based SSH client. If it works. Takes a second. All right, cool. So we're in. I don't know if you can see the text very well, so I'll say what I'm typing as I go. So I'm just going to do a sudo docker ps. It's going to list all my containers that are running on this box. And you can see that there's a couple called guestbook latest. That's my web front end. Just so happens there's no Redis stuff running here. And then there's a couple utility things that are running because it's a Kubernetes managed node. So it's got a couple other containers, Pause and CAdvisor, which CAdvisor is another open source project from Google that gives you health metrics into containers. So what I'm going to do, and this is kind of funny, is it goes too fast almost. So what I'm going to do is I'm going to kill one of these containers. So I grab this container right here, and I'm going to say sudo docker kill, and then I'm going to paste that container ID that I just copied from above, right? Kill that thing. So now if I do a quick list it again, that one should be gone. Yes. Okay, so there's only 4 there now, and there were 5 a second ago, or there's 5 now, and there used to be 6. That one's gone. Now, let me do it again. How long has it been? Oh, look at that. 4 seconds ago, it spun it back up already. So when I was preparing this, I was actually prepared this on really, really bad Wi-Fi on an airplane. And I went to the page, and I was actually able to get the page to show, like, in between killing and bring it back up. Oh, whoa. You guys are all adding to this? Oh, cool. Nice job, guys. Wow. Thanks for paying attention. I guess you can see the screen. No, I was able to actually go to the thing, and it would give a 404 because it wasn't come back up, and then you refresh it and you see it again. I think somebody released a patch or something, but because it is now so fast that I can't even do that. But you saw you just brought it back up. Now that's part of the health model in Kubernetes. You just declare how many containers you want to have running, and it will figure it out. In fact, if I went and killed the VM, which I'm not going to do because it's whatever, we're not going to do that. But if I killed the VM, it would take all that work and it would move it to other VMs as long as it had capacity. So you don't have to worry about like which VM's running where. VM dies, it's going to spin it back up somewhere else. And I'll show you some other cool stuff in a little bit. Let me get back to the presentation, and then we'll keep going. What do you guys think? Is that cool? Is that kind of cool-ish? All right. All right. So design principles of Kubernetes itself. Declarative over imperative, meaning say what you want, not how to do it. And you get more creative when you work with your kids or something. You tell your kids what you want. They get creative solutions. But the flexibility there for Kubernetes is that you don't have to go through and command it like, no, you're going to run this exact process on this exact machine. You say, I want to have 10 of these. I don't really care where they run. I want 10. Keep 10 running. Okay. Control loops. This is how this is actually happening behind the scenes. It's watching. It's always watching. It's comparing current state to desired state, and then it's making sure the current state matches desired state. That's sort of that loop. Keep it simple. Simple, simple, simple. We try to remove as much from the system as we can. And that's actually an important thing to realize when you build a system like this. The experience that the engineers that had been working at Google in Borg and Omega codename projects, they'd already gone through the hard mistakes of adding the wrong features. They'd already gone through that. They knew it needed to be done to make it work across a broad set of applications. Modularity, keeping things pluggable, independent, composable. Legacy is really important. It's really important that realize every single person here probably has some application code they already have that's already running somewhere. So if you're going to get on the quote unquote containerization bandwagon, you don't want to go start from scratch. You don't want to have to go learn a whole new set of technologies. You want to take what you already have and be able to move it. And if you're already building applications that run in Linux, you pretty much can move to containers. If it runs in VMs, you can pretty much move to containers. IP addresses are cheap. Networking is a big part of making this work because especially when you're in a cloud platform, being able to let things talk and address each other. I'll talk about that a little bit more in detail. It's kind of hard in the abstract. We use this concept of labeling, and it's the only grouping that you have. So, and I actually have some slides on that too, so we'll talk about that. But the idea is that you have these labels, and you get to do whatever you want. We don't have a hierarchy of the containers. You label them in a particular way, however, based on conventions. There's some conventions around it. And you can then address those things based on their labels. So you kind of can define your own grouping that works for you, which is there's a lot of freedom there. Managing your workload in bulk. Think about this is a metaphor we use, and it maybe isn't totally PC, but with that caveat, I'm gonna say it anyway. You think of it as pets versus herds. So you think of if you have an application that's this pet that you take care of and you feed it and take it to the vet, and it has a name, and it's like a part of your family, right? That's kind of like, some applications are treated that way. Maybe your database is treated that way. A lot of databases, I think, are treated like pets. Versus cattle, which is, it's a herd, and you're managing the herd, and yeah, you're going to have, there are individuals to that herd, but you're looking at it at a much higher level. You're thinking about that herd of cattle as an entity unto itself, and that's kind of the transition that you make. So every time you think about this is a generic, arbitrary, unit of compute that you have in your container. So, I hope that wasn't too offensive. And then open versus closed. We're really believe in openness. Google's really big on open source and open community. It's why this is an open source product, and open source project, I should say. And that's why we're working with so many other parties to make it real. And we're using lots of open standard stuff too, REST and JSON, etc. All right. Okay, so let me talk about the concepts in Kubernetes a little bit, because these are important sort of primitives. This is the primitives of Kubernetes. So container is the unit. I think we've talked about that one sort of ad nauseum, but that's the smallest unit, which is that's where the sort of rubber actually meets the road, where the work is happening. The pod is a tightly grouped set of containers. And it's important that you have this concept of being able to have containers run together. It gives you more modularity and composability. So the example here the example is not, you would have a pod that has both your web front end and your database in one pod. That would not work. What you would have is the units that compose your front end would be in a pod together if you needed more than one. So you could have a set of libraries, for example, or you might have some tools for debugging. Put those in their own containers. Make them a part of the pod, and then you can actually work with that set of containers without polluting your application production code with a bunch of other stuff. That's one way of thinking of it. Or this example of you have a web server, and then maybe you're pulling content from some static location. You maybe have a GitHub repo that has all of your docs or something, and you're pulling that content from one container, and then you have another container that's doing the serving. So they're two different pieces. So that way, if one of those changes, God forbid that you actually have to change your software at some point, you can replace one without replacing the other. So that's a pod. And then a controller is the loop. We talked about the loop already, but that's the one that is primarily used as a replication controller. Replication controllers basically let you set a number of how many pods you want. You say, I want to have 10 pods. I'm going to keep it at 10 as best it can. And I'll show a little of that in a minute. Service, which is a super unique word that we invented. We made that up. A service in the context of Kubernetes is a pointer, if you will, a load balancer, if you will, to a group of pods. So you say, these pods all do the same job. I want to be able to address them as that herd of, or pod of, I guess I can't use pod and herd in that context. It's like a pointer to the herd as opposed to a pointer to the animal, if that makes sense. So it's a way of addressing a group of pods that all have a similar function. Labels, I talked about a little bit. Labels are key value pairs, a way of describing and finding parts of your application. And then the selector is the query that finds a label, right? And I have actually some cool slides on that. So pods, P-pods, pod of whales, those are pods. Here's a pod of Docker containers. They're hanging out in the water. All right. Okay, I'm double-clicking on pods now. So very tightly coupled. They always run on the same node. They share fate, meaning that if one of them dies, they all die together. This is where Kubernetes is really never managing individual containers at that level. It's really thinking about it in terms of pods, which is one or more containers. So even though there may be a one-to-one relationship in your app or parts of your app that are, this pod has exactly one container, it's important to make the mental distinction that the pod could be more than one container, and there could be more than one copy of that container via pod. They share an IP address. They can talk to each other via local host, which is kind of cool. And they can die and be replaced. And I already talked about the web polar thing, so I won't go through that again. But you can kind of see this diagram here. So there's one pod. There's 2 containers attached to a single volume. Because keep in mind, these are just part of the operating system. They're sharing, if they're running on the same node, on the same VM, they're already sharing an operating system. It's really the same computer that's running it all. Okay, networking. So the pod IP is a routable IP address. You can reach each other without NAT, even across nodes. This is an important design principle of it. And there's no brokering of port numbers, so you don't have to worry too much about port number collisions, which is kind of nice. And there's a bunch of SDN, so software-defined network solutions, which I was going to try and remember them. They're in my notes. It's Weave, Flannel, and a couple others. I don't know. You can Google it. All right. So here's a diagram, a nifty little diagram of some pods talking via networks. So you see these are three different nodes. They're all communicating over IP. They can talk to each other. It's really a big part of how it all works. So you may have to change some stuff in your app if you're using like inter-process style communication. But really, if you move everything to talking over network, you're going to have a much more scalable app anyway. So, and if you use something like Google Cloud Platform or clouds where everything sort of, you have high performance networking in that case where they're talking to each other within those networks. So, okay, so let me talk about labels. Let me move on from networking. Labels. Any metadata, arbitrary metadata, anything you want to have in your app for reporting purposes, for a dashboard, for application logic. If you actually use use a Kubernetes tool set, you can actually use labels as a way of communicating between parts of your app, which is kind of cool. We use them for identity. We use them through the selector. So selector, think of it as a query. So you can see I'll walk through a few slides about this. And it's the only grouping mechanism. It's the only way that you can group a set of pods. You can explain what their role is in the world. But you can use whatever you want. So you could say, this is my foobar, this is my web, this is my mobile, this is my whatever. And you can also describe things. Here's some examples. This app is called Nifty. It's got different phases, and it's got different roles. So you got front-end role, back-end role. You've got dev and test, and this app called Nifty. And so if I use selectors, what I can do is I can say, show me everything that's part of Nifty. So imagine there's other apps too. So give me the Nifty. This gives me everything. Give me just the Nifty front ends. Give me my Nifty back ends. Give me just everything that's in my dev. Give me everything that's in test. So you've taken now your big pile of compute resources in your data center or cloud, whatever. You got this big, massive pile. You stuck a bunch of containers on top of it, and you have a way of describing how those containers actually fit into your development lifecycle. So whether that's part of your continuous delivery development cycle of being able to push things into different environments for testing purposes, or if you want to give every developer their own test environment in the cloud, you want to do phased rollouts, et cetera, you can use labels as a way of describing those concepts. Not just the application itself, right? Also your sort of business rules around how you're going to do deployments, how your teams are going to work together using those containers. Okay, does that all make sense? Okay, we had a question, yeah.
So with those labels, I mean, do you have a concept of hierarchy in there, or it's just something that's something that's something in the label? Or I mean, it would just seem to me that something gets big enough, you would need hierarchy.
Yeah, so you can do. So the question was, is there a hierarchy or is it a flat set of labels? So it's implemented as a flat set of labels, but you can impose a hierarchy through convention, which is the way that it's recommended, because your hierarchy is not going to necessarily match somebody else's hierarchy. So you can create a namespace style hierarchy yourself, and you can do that through either having more key value pairs or having keys that describe their hierarchy. If that makes sense, yeah. Okay, cool. All right, control loops. I think I talked about this already, but it's just nice to have the diagram because you can think of it as a loop now. You can see the circle, the donut. Observe, find the difference, and act. This is the whole model behind what's driving. That's the engine that's constantly driving Kubernetes to match current state to desired state. Yeah, no shortcuts, observe truth. Yeah, all right. Yeah, so notice replication controllers actually use selectors. So you've got your pods, they've got containers in them, they've been labeled properly. Now the replication controller can use those labels to actually observe and match state. Here we go. Here's a slideware demo. So here I've got 4 nodes, which are VMs. If you see the word node, just think VM. it's more generic because it could be just a bare metal machine, but like that's what we mean when we say node usually. You got 4 pods. Each pod is running 2 containers. Desired state is 4, current state is 4. So we don't have to do anything. Everything's fine, right? Oh no. The lightning struck and took out your node, which is unfortunate. So that guy's gone, right? So now our desired state is still 4. That hasn't changed. But now our current state is 3. So what are we going to do? But bring back up the node, right? No, we're not going to do that. We've got room on node 3. So we're going to just pop that pod back over there. We're fine. So by having some headroom in your different sites and your different VM infrastructure, that's it on that one, you can actually, as things are dying, it's just going to get moved for you, and you don't even have to think about it. And because you built everything using labels, it doesn't really matter. There's nothing special about the pet that was running on there. It's a part of the herd, right? And it's going to be able to move to a different set of resources. So when you think about your VM infrastructure being fungible, basically, reusable, shareable, you're getting this nice separation between what's inside the application that developers care about and what's outside the application, which is what operations care about. So that that kind of creates DevOps, if you will. But being able to do those two developer activities and operations activities very different, separately and focus is a big part of it. Okay, so then I think it's time for another demo. This one I'm going to do with a video because I don't know, I'm feeling like it. So let's see if I got one. Okay, this. You guys interested in rolling upgrades? How that works? I can show you that too. But why don't we just do the? Okay, so oops. If you know how to use a Mac, that would be good. Okay, so what this is going to do is it's going to take an application very similar to what we saw before. Very similar to what we did before, actually. And we're going to try resizing it. So instead of killing and bringing it back to life, which is changing the current state, think of it as changing the desired state. So to start out, you notice this command we're running, resize. I should put my hands here and pretend like I'm typing, right? Yeah. So we're going to resize the application. And this is an application it's really simple. Each container renders one of these little boxes down here with the Nautilus, which is a kind of shell, the Nautilus logo. And you can see what happened there. So we just updated from 2 to 4, and boom, 4 replicas up and running, just like that. I mean, that fast. And so, that may look like magic, right? But like demoware. But what's going on behind the scenes is you're actually booting up new containers. You're taking a container image that's already there, and you're booting up these new pods, you're booting up these new containers, and they're running and re-rendering the screen. So, you could imagine that being different parts of your application that need to get scaled. That could be, hey, we do batch processing once a month of all of our billing data, so we need to spin up, these things, but only for a few hours. Being able to do that without like a huge amount of headache, and being able to move your workloads around pretty easily. So let's see. There's another minute to this demo. I think I showed enough, though. I think we got it. I'm going to show you rolling upgrades while we're waiting. I don't know what I'm waiting for, but. All right, rolling upgrades. This is actually super cool, too. So containers, they're stored as images. Okay? So think of it kind of like a VHD file, or a VM, whatever your ISO file for a VM. And those images are built from your source code and from dependencies on other images. So you have base images, and you kind of build them up in layers. Those images can easily get deployed and up and running, but what if your new sort of desired state is, I have a new version of my application? Or what if I have a new container image because of underlying dependency change? The new version of Java came out or whatever. Or maybe there's a virus or vulnerability. So, and you need to get the images redeployed. So this is how you do that, is you basically just run, let's see what the commands we're going to run. Google compute SSH, you're going to SSH into the box. And you see that this is the same application from before. We've got 2 Nautili, I think is the word. Once we SSH into the box here, my friend Brian made this demo actually, so I watched it earlier. So he's going to go sudo docker ps like we did before, and look for all the Nautilus ones. So you can see there's exactly like we did before. We see the list of all the Docker containers running on the box, and we've got the ID of the container, and he's going to guess he's killing that container first. Oh, you know what? I'm sorry. This is the same demo I gave earlier, basically. He's just going to kill that container. All right, I'm sorry. Rolling updates. Let me just say how it works. You update it. You just run a command that updates the image name, and what we'll do is we'll roll out new pods and kill all the old pods. So you just get a rolling update. Sorry, I didn't have a demo for that. I apologize. I thought I had one. That's bad. All right. Okay, cool. Moving on. Services. Another Kubernetes concept. And we talked about this a little bit. So it's a group of pods that act as one. They're all working together in concert to provide a service to other parts of your application. So a way of addressing that is one thing. So behind the scenes, or the external thing that's talking to this service doesn't care that there's 8 or 1,000 pods. They don't care. They just want one place to talk to. It says, give me this thing or do this work for me. The service then has this load balanced concept. That's the way it's implemented now, but there's some ideas around some different ways of doing that portal to the other pods. And you get a stable virtual IP address and DNS name. And you have a VIP that's captured by our kube proxy, which is part of the Kubernetes system. And we'll watch for the constituency, which is basically just the, do I have the right stuff? And sends the work to the different actual pods, which then in turn turns it to the actual containers and does whatever it needs to do. So, and it's all based on labels and selectors as well. So you see that again. Using the labels means that Kubernetes and the way you think about your app can all fit together. All right. Here's a little more diagramness. See, we named it as Nifty Service. It's got a selector. It's got a port. It's got a container port. And you have an ID, IP address assigned to it as well. So there you go. Cool. All right. So then a little bit about like where we're going or what we've done, I guess. So I already said we open sourced it last year. We actually won Rookie of the Year from Black Duck this year, which golf clap for that. And then we launched the container engine. It's in an open alpha right now, so you can go use it. You just pay for compute on Google Cloud, and there's I think it's a $300 sign-up thing. So if you want to go play around with it, you don't have to get charged. I encourage you to do that. The roadmap is out on our GitHub site, and we just made a bunch of updates to that based on the meetup we had a couple weeks ago. A lot of focus on stability, networking improvements, making it work really well on premises. So some of the key things we're working on. We are planning a 1.0 release of Kubernetes when it's ready, when the quality's there, when we're happy with it. Should be in months, not years. Hopefully weeks, not months. We'll see. But being able to scale up a little bit bigger, run more nodes, run more pods, and do that in a provable way where it's not just, hey, we think it'll run, but actually have some data around that. And really looking at sort of these web scale style use cases as a starting point, but there are people who are playing around with it for lots of other things, different use cases. So that's kind of where that's at. Yeah, it's kind of a new way of working. It's a way of shaking things up. There's a lot of concepts. I hope that you got some of those concepts through this part of the talk about Kubernetes. And I know it's like, it takes a little bit of like adjustment to get the concepts and then apply that to your applications. But I think the biggest thing is to go play around with it. That's like the coolest way to learn. Okay, I want to talk about one more thing, and then we'll do more interactive maybe. Google Container Registry. So when you have container images, you need a place to store them. There's a couple ways you can do that. Docker Hub has a public website you can go to where there's images and you can download them into Docker. You can take dependencies on them. We launched recently into beta the Google Container Registry, which is a Google service, Google Cloud Platform service for storing your containers. I'm going to do I have a demo video of this one, and I know I actually have this one. It's secure, meaning that it's the same OAuth that you've got in the Google Cloud Platform. We actually went into the Docker project and added OAuth support into Docker itself so that when you pull, you can use the same login that you use with Google Cloud to get into the Docker container downloads. It's super inexpensive, and I don't know if you guys saw this morning, but we announced some updates to our storage. anyway, so inexpensive, scalable storage. It's stored right next to your, if you're using Google Cloud Platform anyway, it's stored right next to where your VMs are running, so that it's free to download, it's fast to download. But we have some people who are already using it. They have Kubernetes in another hosting provider, and they're using Google Container Registry to store their images. So it actually fits into different models. You can use it also if you're not using Kubernetes and you're just using Docker on Google Google Compute Engine. You can also use the Container Registry. So let me just show you. I mean, if you let me here, got a video. So this is a video prepared by Jeffrey Van Gogh, who is my partner in crime on the Container Registry. So what we're doing here is we got an app. We're doing a Docker build. I apologize if you can't really see this. It actually goes kind of fast. So I'm going to pause it here. So here's what happened. So we did a Docker build, and we used this gcr.io, which was like the shortest URL we could get. It stands for Google Container Registry.io. And so you use that same URL to reference all of your Docker images. Normally it's your username. If you're on a Docker hub, it's like whatever username you signed up / container image name. And so with this, you just say gcr.io / username / container name, and you can get it references directly. And then you can see this gcloud preview. We use the preview in the command line. It's just because it's in beta. It's we make sure so people don't accidentally run beta commands. We make them type preview. That will get removed once we actually go to general availability. So that's why it's gcloud preview docker push gcr.io /cube gcr /hw. HW is the name of the container image. So that is sending the image up, and let's see what happens next. Okay, demo gods, hopefully it works, right? That's how, no blue screens. So it's going to upload the image, pushing, buffering, sending it on its merry way, and look at that, it's pushed. A couple more. Now what's cool about this is because it's using the gcloud commands, it's using the same authentication that it used for that gcloud account. So for my Google Cloud Platform account I have the same authentication. I don't have to have some other, plain text or other authentication for that. And if I want to keep my images private, which some people do because they have, proprietary software they don't necessarily want to share into the wild, do that. So then inside of your Kubernetes pod description, this is the JSON file that describes a Kubernetes pod. Kind of flashed fast, so let me go back. So this is just the format that we use for describing pods in Kubernetes. It's pretty straightforward to build. There's plenty of examples on the internet too to steal from, which is what I usually do. You can see the container image name referencing gcr.io / blah, 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 getting HW:/latest. And here we go. Create gcloud preview container pods create. And passing that config file we just showed you. And guess what? It's going to create a set of pods on that cluster in Container Engine using the image. And it downloads super fast because it's in the same exact place. All right. Cool. So that's that. See how the guestbook's doing. Nice. Okay. We'll play with that later. All right. Oh yeah, I'm supposed to do a demo. There we go. All right, just a shout out here. Kubernetes is open source, which means we would love your help. And you now know a little bit about Kubernetes, which is good. Yeah, go on Kubernetes.io or GitHub, and then next time you can have a sticker. Actually, there are 3 stickers left, so whoever's first at the end will get one. And we're also on IRC, and we're on Twitter. And I'm on Twitter too, @KidMerker. So anyway, I'll take some questions if that's all right. Yes, sir, again.
So whenever I mention Docker, I get dogpiled by security. I mean, first off, I'm not sure that I understand all the arguments. I mean, to me, it seems like your security perimeter would basically be the same as it is today. But I was wondering, how do you combat that?
So the question is, let's see if I can summarize this. Is Docker secure? I think is the first part of your question. And I think the second part of it is, how do I convince my IT organization that to let me use it? Is that okay? So it's an interesting problem, right? They're working really hard on making it more secure. There have been some security vulnerabilities found in Docker itself that have been patched really quickly. which is really important. Everyone there and at Google, all of our partners that are working on this stuff all take security like ridiculously seriously. So it's one of those things where it's going to improve over time and it's getting attention, and it's there are big players that have a vested interest in making sure it's secure, so it's going to improve in that way. I think that's the first part of it. The second part of is it secure is we like I said before, we recommend running them inside of VMs, and so you're really not adding necessarily a different security perimeter. To your point, you have the VM kind of providing that boundary, and then the container is really just a way of running your process isolation within the VM. So if you're, I would say, to your IT organization, hey, I'm not planning to run Docker on bare metal. I'm not planning. Maybe you're not planning to put it on your front ends. Maybe you're going to use it for development and test and cloud deployment stuff to start. But eventually, you can get to that point. I mean, we're not at 1.0 yet, so we're not recommending Kubernetes in production yet. Docker, I think, is at 1.5, if I'm not mistaken, and so they have people using it in production. So it's going to evolve over time. I think another part of it is if you have a private place to store the images. I think it's another thing that can alleviate concerns because it's kind of easy to accidentally push stuff out to the public. Docker Hub, if you're not careful. So those are other things. So I don't know if that answer your question.
You also said, Google runs on containers, right? Yeah. So, but they're not necessarily Docker containers.
Yeah, that's correct. Yeah.
So, is that stuff open sourced, or that's like a different?
Yeah. So there's a different container technology called LXC that we use inside of Google, and I can't really. So I'm not supposed to talk about like what we actually do inside or whatever, but we're not running on Docker. I can say that. And there are other container technologies out there that you could use that have been around a little bit longer. The thing that Docker really brings to the table is ease of use, and it's just really simple to get started. There's a whole ecosystem around it. A lot of people are embracing it from that perspective. So even though the container sort of Linux level container technology has obviously been around for quite a while, it's kind of getting this like convergence right now with people realizing they need to have better packaging and isolation. People wanting to run more efficiently, running their VM infrastructure more efficiently, and then the tool sets being available. It's kind of all perfect storm style coming together.
LXC's been around for 2009, and there's a concept called C groups, which enables you to secure the LXC container. Docker can use LXC as the underlying technology, but Docker abstracts away so much to make it easy to use that all those security knobs go away in most basic vanilla implementations. And so you have to dive down into the LXC layer, and then can you get there through Docker? Not easily. It's the same thing like when you're using Vagrant. You lose control, and that's what the security guys don't like.
Yes. Well said. Yeah, and back in the day, Google contributed C groups to Linux. That's where it sort of came from. And actually, Docker uses different, and the name is escaping now. They actually were using that technology, but they've moved away from that and are using it their own implementation under the covers. But anyway, thank you for the help there. Oh, wait. So this guy. Yeah, so that's a good question. So the question is, what's the story around Kubernetes and Mesos? So there's some really cool examples of Kubernetes running on Mesos. And we work with the Mesosphere guys on that stuff. You can kind of think of it like, the way I think of it is that you've got resource orchestration, call it. That's kind of what Mesos can do. And then if you want to run Kubernetes on top, that gives you your container orchestration. So it's actually very complementary how they can fit together. Did that answer your question? Sort of.
I feel like I remember there was like a burst of like publicity and stuff like 6 months ago, and then it's been very quiet. So I was wondering, like, do you have any insight into what the future holds in terms of like the relationship between the projects? Or
specifically publicity around Mesos and Kubernetes? I think everybody's just busy working on stuff. I'm not exactly sure. I don't have anything to say about forward-looking plans on that. Thanks. Okay, wait. There's somebody else back here. Oh, this guy, the glasses. There you
go. Could you contrast? I think I know the answer, but I think it would be interesting to hear you said the contrast between Kubernetes and the various platform and service vendors. It seems like this is more of an
Yeah, so so the question is, how does Kubernetes compare, contrast, or fit in with PaaS style solutions? Is that fair? Okay. Yeah. So in the sort of abstract, one of the super power users of Kubernetes could be PaaS style solutions, right? And you see that with OpenShift, and there's some other players that are working on building PaaS solutions on top of Kubernetes and making it even simpler. Because like you saw, there's these primitive concepts of pods and labels and all this stuff that's really open. And if somebody has a specific perspective on how they want to run a platform, make it easier for developers to do a specific problem or a constrained problem within that and be prescriptive, then you just narrow that down, right? You would use it in a certain way and make a decision about it and then expose that to your developers that want to use the PaaS. So I think it's sort of complementary. I think for the other thing is that there are applications that don't necessarily fit into PaaS where you want to have a little more control, or you've got legacy stuff. You're not necessarily wanting to rewrite to fit to a PaaS if you have legacy. And so I think we think that's kind of a good use case for Kubernetes as well.
That makes sense?
Yep. The answer to your question is my 4 o'clock session.
Oh, well, there you go. The answer to your question is the 4 o'clock session. There was another one here. Yep.
Is LXC Red Hat specific only, or
Is
LXC container?
Is LXC Red Hat specific only?
I feel like this is a trick question. I don't think I'm pretty sure it's not.
LXC in the context of Red Hat, so I was curious if you guys are using LXC, and then is Google running on Red Hat?
Google internally? I can't comment on that. Yeah, LXC is Linux. Yeah, so it's not, and explicitly so. I mean, it's very important to realize that you're sharing a kernel and you have a different operating system, right? You're sharing a kernel with a different distro, which is great. That's one of the powerful things about containers is that you do not have to have a homogeneous environment in terms of what Linux distro you're using. So I lost my screen here. I don't know what happened. My mouse died. No, it's okay. Don't worry. I don't have anything else to show, so that's cool. We can just keep chatting here. A little fireside chat. More questions, comments? Want me to explain stuff?
When you defined the pod, you said that it was guaranteed to run on the same node, right, or something like that.
Yeah. So the question was just to clarify how pods are scheduled. Yeah. So yeah.
If you're just a degenerate case, at some point your node's going to run out of gas in terms of resources. How do you know how to properly size your pod?
So the pod is a group of containers, and all the containers within that pod have to run on the same node. So you could have 2 or 3 different pods that are all running on different nodes. That's totally fine. They could be even copies of each other. They could be replicated versions of those pods, instances, if you will, of those pod templates, and they can run across that. You're totally right that you could run out of resources. So degenerative cases of, I have so many containers in my pod that it's just so huge and resource consuming that I can't even fit it onto a VM. That probably is time for some changes to the pods because you're trying to do too much in that pod, right? You can decompose it further. Other cases would be you've lost so much VM capacity that you cannot schedule the amount of pods that you need. That is something you would have to solve with monitoring. And so being able to get that visibility into what's going on would be a part of that. That's one of the things that we're hoping to do longer term in Container Engine and Google Cloud is to give you more ability to identify and autocorrect or set policy around how you manage your capacity so that if you do run into issues where there's you don't have enough capacity, you can kind of automatically get that scaling. If you're in a on-premises style situation, you may not have that capability, so you'd have to look at making sure you've got and the planning windows are much longer or whatever. But I think being able to coordinate between different Kubernetes clusters, if you had 2 or 3 apps, one's getting demand, one isn't, you could kind of scale between those. That would be fine. They can run side by side. So, yeah. Question here. Wait, this guy you already got one, but I feel like you get another one. That's okay. Go ahead. You got the error. So the question is a container registry open source? So there are open source registries, okay, that are out there, and you can use those. This specific one that I just showed is the Google hosted one, and it actually runs on Google infrastructure. So it cannot be open source. It's taking advantage of specific parts of our behind the scenes, but it's running on the same stuff that runs YouTube and Gmail and Google.com, all that fun stuff, all runs on the same infrastructure. Okay, so the question is, are pods, can you create pods of pods? And the answer to that is no, you cannot. But that's sort of okay. You solve that with labels, is the best way to do it. It'd be an interesting use case to pose to the community if they're, but I'm sure they would have an answer for why they designed it the way they did.
Okay.
What about a 12-factor style environment configuration for things like external dependencies that are not within the Kubernetes infrastructure? If you have a dependency on an external thing that will differ between environments, how do you solve that problem?
Yeah, so the question is, if you have external dependencies in your application, how do you, configuration management I think is kind of what you're getting at, how do you make those changes on a per environment basis? Yeah, so probably the easiest way to do that would be with labels. What you would do is set up a label that defines your environment. So you'd say like, okay, this is my test external dependency, foo, whatever. And in the test situation, it is this value. It points to, whatever, 10.0.1. Whatever. And then when you put it in production, you'd have that. So you just store the different configuration files, those JSON files that describe and you would describe those inside of labels. You put whatever data you want into those, as much as you want. So you would just have copies of those, right? And so you'd set up your CI/CD system, for example, so that when it's building and deploying the Kubernetes pods, it would just do that, and then those labels all get pushed into the configuration. Correct. Yes. Yes. And in fact, we're hoping that some conventions. Oh, just again he asked, are they just arbitrary key value pairs? So the answer is yes. And from a convention perspective, we're hoping that some conventions emerge. For example, like if you had an icon that represented your application, like being able to have multiple people consistently describe it that way. And then if somebody built a UI, like a management console for Kubernetes apps, then they would be able to discover the icon no matter whose app it was, right? So but that's more of an emergent thing we expect as the community kind of matures.
Yeah. Any more? This guy.
So like if you have a virtual machine and you're doing like UDP, ping pong, stress test, maybe you get like 100,000 packets a second. And then you go to like kernel bypass, you may hit like millions of packets a second. So are there hardware concepts that are evolving around all this, where you can get higher packet rate between your containers, sort of thing? Optimizing your network stack, like in our.
Yeah, so I would say the best thing to do on that is to look at the GitHub. There's a bunch of PRs on GitHub around networking future stuff and the roadmap stuff there. So I'm not actually I didn't read all of it, so I can't speak to exactly what the plans are. But I shouldn't say that. I'm recorded saying I didn't read all of the PRs, which I will go do now, so that my peers don't make fun of me. But there's some great stuff out there on the networking, and it's also if you have specific use cases and you want to chat with anybody, go on the IRC channel and you can ask them whatever you want, and they'll tell you what's up. Yeah. All right. I guess I still have 15 minutes left. I'm ending early. What do you think? Is it any more questions? I'm not afraid to take one. There you go. They can be, yes. If you use the Kube proxy, you can talk to them. You can talk to labels and see that data. Yeah. And we set a bunch of environment variables inside the container as well that are referenceable. So based on the metadata. So the question is, can you dynamically change labels in an existing deployment? Yes, you can. Yep. Okay, how many people are going to try Kubernetes out? What do you think? That's pretty good. That's pretty good. I can't wait to see what you guys build. It'll be great. Thanks so much for the time.